of RC impedance or RL admittance network, or RL impedance or RC admittance network, or LC impedance network. Impedance means impedance and admittance networks. So for this synthesis of any network, that means RC and RL. RC and RL. That means, so we all know that there are three different elements must be there. What are there? There is resistor, inductor and capacitor in electrical energy. So the network to be synthesized or either RC or RL or LC, whatever may be, when the network to be synthesized, there are number of methods for synthesis at one port network. So what are the most commonly methods, most common forms while synthesizing of RC or RL RC networks? Most common methods are faster form 1 form and faster form 2 and cover form 1 and cover form 2. So these are the 4 most important methods for synthesis of RC or RL or LC networks. So that means impedance to admittance, admittance, one is impedance, another is admittance. RC will be taken as impedance, RL will be admittance. RL will be taken as impedance, RC will be taken as admittance. So LC in terms of impedance and admittance. By synthesizing whatever the RC, RL and LC, we have to use the most common forms are faster form 1, faster 2 form, cover form and cover term. Generally, these faster forms, that is faster 1 and faster 2 forms, are obtained by partial fraction expansion of impedance functions and admittance functions respectively. Faster 1 and faster 2 forms will be obtained by partial fraction expansion of impedance function Z of S and admittance functions Y of X respectively. And the cover form and cover 1 and cover 2 forms are obtained by continued fraction, that is the division method, for continued fraction expansion of impedance function by arranging both numerator and denominator in descending and ascending orders. So by arranging both numerator and denominator in descending and ascending orders respectively, because in the faster 1 and faster 2 forms we are taking by using partial fractions. By obtaining partial fractions expansion, you have to find out impedance and admittance. And the cover 1, cover 2 forms, these cover 1 and cover 2 forms are obtained by continued fraction expansion of impedance functions. So now you say, so generally in the faster 1 and faster 2, when there is already, we know that in the generally if there is the resistance part is there, when you have the impedance part, resistance will be R only. Admittance part you have take 1 by R. Reciprocal of resistance is not, impedance is nothing but the admittance. So R we have to take a G in admittance form. Suppose if L is there, L into S in impedance form, 1 by Ls in admittance form, 1 by Ls in admittance form. You have to remember these things. So generally 1 by Ls means L di by dt. We have to Laplace this equation. L into S into I of S minus I of 0. So V of S is equal to, so L is equal to V of S by Ls is equal to V of S by I of S. Like that you get this form. So R for taking the resistance, in the impedance also we have taken the resistance only, but in the admittance we have taken a G. Reciprocal of resistance will be conductance or 1 by R. And the element L is there, inductance. When you have to find out the impedance, it is in the form of L into S. But in the admittance, it is 1 by Ls. 1 by Ls. When you take the capacitance, in the impedance form, it is 1 by Cs. And the admittance form, it is C into S. So this will be remembered that. So when you have to find out either RC network, RL network or NC network, when you draw the synthesis graphs, then you have to put if their element will be resistor, there is no change. Simply in the impedance R, in the admittance we take G. If the element is inductance, if it will be the multiplication of S, then it will be impedance L into S. Admittance 1 by LS. In the capacitance form, impedance form, it is 1 by CS, and admittance form, it is CS. So this is the faster form 1 and faster form 2 and cover form 1 and cover form 2. Faster form, it is also called as faster series form. Faster form 2, it is also called as faster parallel form. Because in the faster one form, if any elements, whatever the elements you have to find out, it will be connected in the form of series impedance. It will be connected in the form of series impedance. Z of S. In the faster 2, whatever the form will be there, it will be connected in the form of the parallel with the admittance. Parallel with the form of the admittance. Faster 1 and faster 2 form will be obtained by partial differentiation equations. I mean partial fraction equations. But in the faster 1 form, so whatever in the faster 1 form, whatever the elements you have to find out, it will be connected in the form of series. In the faster 2 form, whatever the elements are there, we will be connected in the parallel in terms of admittance, and the faster 1 form will be in terms of the impedance. So, and the cover 1 and cover 2. So, when there is the in the impedance, one is series form and the parallel form. Series and parallel, then you have to connect, that is called as cover form. When the cover, that means in terms of impedance. When in terms of cover 2, in terms of the admittance, that we have taken as the series and the parallel combination. But in terms of the admittance, you have taken in the cover 1 and cover 2. So series parallel combinations you have taken in the cover 1 and cover 2. In the faster form, one is the series and one is the parallel form. So now first you have to know about what are the basic properties to find out these faster 1 and faster 2 and cover 1 and cover 2. So first you have taken synthesis of RC impedance and RL admittance network. Synthesis of RC impedance by RL admittance network. So, what are the basic properties of RC and RL impedance? That means the poles and zeros. I already discussed about what is poles and what is zeros. Zeros comes from the numerator and the poles comes from the denominator. The poles and zeros lie on the negative real axis, including origin of the complex S plane. So, whatever the poles and the zeros will be lie, this will be comes to the negative real axis. That means both are in, there is no positive real axis, real numbers are there. There is no imaginary terms also there. Only negative real terms are there. The poles and zeros lie are the negative real terms. Next, the poles are interlaced along to the negative real axis. Interlace means alternating. If suppose first one is pole, second one is zero. First one, another, third one is pole. Next, all one pole, 1 0, one pole, 1 0, one pole, 1 0. Like that, it will be interlaced along with the negative real axis. The residues of the poles must be real and positive. The residues of the poles must be real and positive. That means whatever the, suppose there is the in the numerator s plus 1 into s plus 3, in the denominator s into s plus 2. When you have to find out the partial fractions a by s plus b by s plus 2, in the what are the a and b values are there, they must be positive. They must be positive. The residues must be positive, real and positive values. Next, the singularity nearest to or the origin must be a pole. Must be a pole. The singularity nearest to or origin must be a pole. So whether nearer the origin, it will be a pole. Then only it will be called as RC impedance or well admittance. If it will be zero, the singularity nearest to the or infinite must be a zero. Then it is called as RL impedance and RC admittance. RL impedance and R. There is only remaining structure must be same, but remaining whatever the properties above must be same for RC impedance and RL admittance and RL admittance and RC impedance. There is only one change. The singularity nearest to the origin, at the origin must be a pole. When it will be the must be a pole, then it is RC impedance. When it will be must be a zero, then it will be RL impedance. Then it will be RL impedance. So what are the properties in this, please? The poles and zeros lies on the negative real axis, including the origin, and the poles and the one pole and one zero, and whatever the residues of the poles must be real and positive, and the singularity nearest to the origin, whatever the point, either the first point will be comes to only pole and then zero, pole and then zero, like that only it will become or nearest to the origin. It will be from at the point of origin or nearest to origin, it will be the compulsory pole. When it will be the RC impedance and RL admittance. If suppose it will be RL impedance and RC admittances, it will be, what will be there? It will be zero. It will be zero. So this synthesis of RC impedance or RL impedance. See that f of s is equal to s plus 1 into s minus 3. And in the denominator s plus 4 into s plus minus 8. So when you have to take and the zeros are in the numerator, s are, what are the zeros? Minus 1 plus 3. Here minus 4, minus 8. But I am telling that all the zeros and poles are in negative real axis. All the zeros and poles are in negative. But here one is positive is there. So this will be satisfy RC or RL impedance. Because if suppose s plus 3 is there, then it will be satisfied. But s minus 3, so one value will be comes to the positive real axis. So this will be not possible. Next, second thing. S plus 2 into s plus 5. So zeros are 2, 5. Okay. Minus 2, minus 5. And 0. S equal to 0. And s equal to minus 1. S equal to minus 1. S equal to 0. And s equal to minus 1. So 0 means that will be pole and it will be minus 1. So I am telling that one pole, next one is 0, next one is pole, next one is 0. But there is after 1, after 0, again the pole will become one pole and another one is pole. Next one it will be 0, next one it will be 0. So this function is not possible because the interlace will be, one is the pole, other one is 0. One is the pole, other one is 0, like that. But in the second equation, 2 are coming from the poles only. So this is also not satisfied. In the third function, s into s plus 8 by s plus 1 into s plus 9. So s into s plus 1 into s plus 9. So when you have to find out this is the s square, that means s plus 1 and s plus 9 must be there. When you have to find out the residues of this function, they comes to the negative. So this function also not satisfied. And when you observe this, s plus 1 is s equal to minus 1 and s equal to 0. But I am telling that when you have to find out the RC impedance, the nearest to the origin or at the point of origin must be a pole. But here the 0 will become in the zeros point of numerator, 0 will become. So whenever it will be 0, this condition does not satisfy. And finally, When you take this condition, all the properties are taken. That means all are in positive. Whatever the zeros and the poles comes to the negative real axis. And the second one is there is alternate. That means one after to another will become one pole, one zero, and the nearest point will be the origin will be a pole, and whatever the residues we have to come all are positive. So this condition will be satisfied for the RC and RL impedance. For RL impedance and RC impedance also the same rule will be followed. Same properties are followed. So one thing will be different is whatever the nearest point of the origin is 0. Nearest point of the origin is 0. Okay. So when you take a simple problem, f of s equal to 3 into s plus 2 into s plus 4 by s into s plus 3. By using the partial fractions of this, that is a by s plus b by s plus 3, first you put s equal to 0 and put s equal to minus 3 in this equation. We get a value and b value is there. This is the partial fraction equations. So whenever you get the partial fractions, so how you find out the, so 8 by s, so 1 by s, so 1 by s. So when you come the by s, then what you have taken? So when you come the by s is in the impedance form, by s is coming from the capacitance. So we have taken is 1 by 8 is capacitance. Next one is 1 by s. Again 1 by s is there. So 1 by s means again it will be by s is come for capacitance in the impedance. So you get the capacitance again. And another one is 1 by 3. So 1 by 3 is nothing but the resistive point of view. So you get the simplicity will be, but this combination will be in the parallel and it is one series, and 3 is in only resistors form. So we get one is capacitor and then resistor, and then the combination of resistance and capacitance in terms of impedance form. When you get in the admittance form, total will be connected in the parallel. So why you getting this? I am telling that when you find out the impedance form, the resistance will be simply R. Inductance will be L into S. Capacitance will be 1 by Cs. Okay. So when you have to find out the resistance form, impedance form, here RC will be the combination because the total value comes from the 1 by S. If I am taking in terms of the admittance form, when it will be the admittance, resistance will be the reciprocal of the resistance will be conductance. Same thing will be there. But whatever the impedance must be there, it will be 1 by Ls. And the capacitance must be there, it will be C into S. So when you have to write down in the admittance form, the total figure in the form of parallel, but it will be the combination of R and L. When you write down the impedance form, the total figure in the series, but is the combination of RC impedance. Here, like that, you have to synthesize the figures. Next one, how you find out the continued cover 1 and cover 2 by using this continued fractions. When you have to using the continued fraction, what you have to done is that generally when you have to use the continued fraction, the numerator will be more compared to the denominator, and that means it will be vary with the numerator value and denominator value will be varies the unity purpose. So here 3s square plus 18s plus 24 and here s square plus 3s. So how you have to do the continued fraction means 3s square by s square. First term of this and this first term of this. 3s square by s square. S square cancel. What is the value? 3. So s square into 3, that is 3s square. 3s into 3, that is 9s. So 3s square cancel. So the sum will 9s plus 24. Again, whatever the s square plus 3s value you have to put here. You have to put here. And then what is the form? Now you have to divide s squared by 9s. 1s and 1s will be cancelled, s by 9. Then you have to multiply 9s into 1s by 9, it gives s square, and 24 into s by 9, that is 8s by 3. Now what is the value? 1 by 3 into s. Again you have to multiply 9s plus 24. So 9s by s by 8, then we get the value of 27. So when you have to multiply this, again the value will be cancelled, then 24 will come here. Next, 1 by 8s. 1 by 8s by 24 we get s by 22. Then again the total will becomes to the 0. So whenever you have to find out the continued fraction, so there is no negative terms must be come here. Negative quotients must be come here. And the total part will become at the point of the 0. So 1 will be the, if there is no s in this place, so this is resistance. And here into s means impedance and resistance, and by s by 2, so into s only, by upper part, so it will be impedance. So resistance, impedance, resistance, impedance. Resistance, impedance. So when you have to figure, show that, so one is resistance and one is impedance. One is resistance and one is impedance. So when there is the impedance form, L into S. When there is the admittance form, 1 by Ls. So suppose we have to find out the cover two fractions, then simply we have to write down in the decreasing order 24 plus 8s plus 3s square. 3s plus s square. Same thing you have to find out the continued fraction in terms of y of s. Suppose we get the value here minus, then you have to reciprocal of the total equation, and then you have to find out the continued fraction. Then you get the equation like that. You have to find out in terms of z of s it is RC form, and in terms of y of s it is RL form. Same thing, what are the properties of RL impedance and RC impedance? I am telling that whatever the properties means, the total will be comes to the negative real axis, that is poles and zeros lies on negative real axis. Poles and zeros of RL impedance are located on negative real axis, wherever the same thing will be comes to the last points, and the poles and zeros are interlaced, alternate in revolve. So one is pole, one is zero, one is pole, one is zero, one is pole, one is zero. Next, the residues of poles, RL impedance or RC admittance, is a function of real and negative. Whatever the poles will become, it will be real and negative. Next, whatever the singularity nearest to the origin is 0. Nearest to the origin is 0. Nearest point at the origin is always 0. It will be 0. But in RC impedance, the nearest point of origin will be pole. But RL impedance, the nearest point will be 0. So this for RL, that means RL impedance and RC impedance. I will show the example in the next slide. First, same thing, what are the properties of LC impedance means? Impedance or admittance is the ratio of odd to even or even to odd. Whatever the function is there, it will be that means it will be satisfied Hurwitz polynomial. Like in the Hurwitz also we have to take an even to odd or add to odd. That means the continuity fraction must be there. Next, the poles and zeros are simply and lie on the imaginary axis only. For LC, it will be lie in the imaginary axis only. But RC and RL, it will be lie on the negative real axis. And poles and zeros interlace on the imaginary axis, j omega. That means one is pole, one is zero, one is pole, one is zero, like that. And the highest power of numerator and denominator must differ by a unity. The lowest power also differ by unity. If suppose numerator is s power 4, the first power, and the denominator of highest power is s cube. What is the difference? 1. Like that, the numerator and denominator powers must be unity. There must be either a 0 or a pole at the origin. In the origin point of view, there is either there will be pole or 0 must be there. That is called as LC impedance network. So basic difference you have to send RC, RL and LC. For RC, the complete whatever the properties must be there. So this will becomes to the one is negative real axis for RC. Like that in RL also negative real axis. But in LC, it will becomes to the imaginary axis, the poles and 0. And in RC and RL, it will be interlaced. One is pole, one is 0. One is pole, one is 0. And RL also one is pole, one is 0, one is pole. But LC also one is pole, one is 0, one is pole, one is 0 in imaginary axis. And the third thing is there, whatever the nearest point of origin in RC impedance will be pole. Nearest of the origin in RL impedance will be 0. Nearest to the origin in LC impedance will be either a 0 or the poles. These are the properties. Then you have to show a simple diagram. That means examples of this. Consider Z of S is equal to 5 into S plus 1 into S plus 4 by S plus 3 into S plus 5. So Z of S represent RL impedance because it satisfies all the properties, but the signs of Z of S are poles and negative. Simply one you observe here. First term will be 0. First term will be 0. So S equal to minus 1. So minus 1 will be in the form of origin, it will be 0. So whenever it will be 0, then you have to think that it is RL impedance. Then you have to think that it is RL. If suppose SC plus 1 is in the denominator point of view, then you have to think that it will be a RC impedance. Like that you have to assume. If it is S squared is there, then you have to put it as LC impedance. So now Z of S equal to 5 into S plus 1 into S plus 4 by S plus 1. So here when you observe this, S into S, S squared. S into S, S squared. That means 2 are in same, when you have to take in the partial fractions. One is numerator is greater than, numerator is less than the denominator. Then you have to take in as a partial, then you have to take in as a continued fraction, and then you do partial fractions. If numerator is greater than denominator, you simply do the partial fractions. If suppose numerator will be less than the denominator, you get the continued fraction and then you do partial fraction. If the numerator and denominator coefficients are equal, that is S square, then you have to put simply, you have to expand in Z of S by S. So you have to multiply, divide both sides with S. So then you get 5 into S plus 1 into S plus 4 by S into S plus 1 into S plus 4. Then you have to take in the partial fractions for this equation. A by S plus B by S plus 3 plus C by S plus 4. So A by, first put S equal to 0 in this fraction. Then S equal to minus 3 in this fraction. Then S equal to minus 5 in this fraction. Then you get the partial fraction equations. So these are the terms coming from the partial. You have to multiply S in this equation. Then 4S by 3S, SS cancel, then it will be 4 by 3. 5S plus 3 into S plus 3. So 5 by 3 into S by S plus 3. 2 into S by S plus 3. So when you get the impedance form, so first one when you observe 4 by 3, there is no S value is there. So simply you have to take it as the resistance. In second one, 5S by 5 into S by S plus 3. So 5, then you get to observe this 5 by 9, 5 by 3. So one thing we have to observe, 5S by S plus 3, then S cancel, simply we get the 5 by 9. Next thing we have to take as 5s by 3 into s plus 3. Then we have taken here the s value will be considered, but this s value will be into s. This value will be into s. For that, when you have the into s, this is the impedance form. Same thing, 2s. Into s will be impedance form and 2 by 5 will be one resistance must be there. So we get the resistance, inductance, and one is resistance. When it will be the into s, we have taken as a common 2s by s. Yes, cancel. Simply there is 2. So we have resistance 2s by 5. So there is multiplication of s. So whenever it will be multiplication of s, we have the inductance form. Same thing. 5s by 3 into by s. S cancel, simply 5 by 3. 5s by 3 by 3. So 5s by 3 into 3, 9. 5s means into s, multiplication. So we get the inductance form. In the 4 by 3, there is no s, so we get the resistance form. Like that, you have to denote the in terms of impedance. When we have to denote in terms of admittance, that is second faster form, y of s equal to s square plus 8s plus 5 s square plus 9. So simply, when you have to find out this, when the two are in same, first we have to divide this. So s square plus 8s plus 15 into s square plus 5s plus 5. Then you get the fraction like this. Then you have to take in the partial fractions like this. And then what are the values you get? 1 plus a value is 8 by 3 into s plus 3 and b value is 1 by 3 into s plus 4. Simply 8 by 3 s. Okay. This will become into s. So 8 by 1, that is 8. And 8 by 3 into s, that is 3 into s will be the division form. So when it will be, when you have to find out second faster will be taken as admittance. In the admittance, 1 by s will be comes into the lower term, that is 1 by ls, that is admittance form. So we have taken, it will be the inductance. Like that, resistance, inductance. If suppose this value will be given as in the impedance form, we have to find out in the first faster. Then you get the values of 1 by s. This is taken as a capacitance. Like that you do. Like that, first cover of the function. How you find out the first cover? So s square plus s square plus 3 7s are 21. Plus 3s plus 7 3s are 21. Like that, you have the s square plus 10s plus 21 into s square plus 6s plus 8. So then s square by s square 1. You have to multiply this. And then its value is 4s plus 13. Then you have to take in this value s square plus 6s plus 8. Then you have to multiply s square by 4s. Then you get the value s by 4. You have to divide the total term in this function. Like that, up to you have to do 0. So first then means resistance. And second one, when you have to take in the impedance, s by 4. So s into s will be inductance. So one is resistance, another one is inductance. Again it will be resistance. Again it will be inductance. Again it will be resistance. Like that you get the total value. Cover 1. Suppose cover 2 must be there. So in the cover 1, when you observe that s square, the same will be there, but you get the here. In the cover 2 form, it will be z of s equal to 10s square plus 12s plus 1, 2s cube. The powers must be differentiation of 1. So when you take the whatever the equations must be there, we have to divide the total equation, then you get the form. So 5s means into s means we have taken as inductance. In s, L, C. So that network will be combination of the L, C. Like that for a continued fraction. So when we have to find out cover 2, this is the cover 1. when you have to find out. And when you have to take as the cover 2, it is in the decreasing order. 1 plus 12s square plus 10s4 and 2s plus 2s cube. Like that you have taken 1 plus 2s square plus 10s4, 2s plus 2s cube. Like that 1 by 2s multiply. 2s into 1 by s, that is 1. 2s cube into 1 by s, that is s square. Same value will become, and then you have to multiply this term. Then 2s by 11s square, it is 2 by 11s. Then you have to multiply total term. And then the whatever the value will be there, you have to write this value. Ls square by 2s cube by 11. Then you get 121 by s. Then you have to multiply up to this function. You get the 1 by s. It's taken as the admittance form. So 1 by s means admittance. It will be taken as the how you get the in terms of the 1 by s, it is inductance, and another one it will be capacitance, and then it will be inductance, and then it will be capacitance. Like that you have to note about the LC networks. LC networks. Like that some of the problems are there. First and second faster forms of the network. Z of s equal to s plus 1 into s plus 3 by s into s plus 2. Like that same partial fractions you have done. Under the partial fractions, then you have get the values. Then you have to find out what is the, which this function will be RC or RL impedance. Different faster techniques and different faster forms must be there. Here, when you observe one thing only, when you observe here, for there is the 3 properties must be there: RC, RL, and RC impedance, RL impedance, and LC impedance. For RC impedance, the whatever the values must be there, poles and zeros must be negative real axis, and then another method means it will be interlaced one nature, 1 pole 1 0, 1 pole 1 0, and the nearest point of the origin will be a pole. For RL impedance, the all poles and zeros must be a negative real axis. It will be interlaced one nature, but the nearest will be origin. And third thing, in the LC network, all the poles are lying in the imaginary axis, poles and zeros, and they interlace one in each other, and the nearest point of origin will be either pole or zero, and the whatever, when you have to find out the LC, the numerator and denominator will be the differentiation of the one. It will be satisfy the that means the total sum when you have to find out, it will be satisfy the Hurwitz polynomials. Like that you have to synthesize RC impedance, RL impedance, and RC impedance and RL admittance, RL impedance and RC admittance, and LC impedance functions. LC impedance function means both impedance and admittance functions.